Hello and welcome. Today, we're diving into a material that is quite literally all around you, but you probably never give it a second thought. It's the silent, unsung hero that forms the backbone of our modern world.
So let me ask you this. What's the one thing that connects those giant skyscrapers that scrape the sky, the car you drive to work, and maybe even the chair you're sitting in right now? They all share a fundamental secret ingredient.
And that's it, right there. Mild steel. It's not flashy, it's not some exotic new discovery, but you know what? It's one of the most incredibly useful and dependable materials humanity has ever worked with. And today, we're going to figure out exactly why.
Okay, so to really get a feel for this material, we have to start at the beginning. We need to understand its core identity. What actually is mild steel? It all boils down to one simple thing: carbon. Mild steel, which you'll also hear called low-carbon steel, has just a tiny, tiny amount of carbon in it. We're talking less than 0.25%. And that small detail, that's the secret sauce. It's what makes the steel softer, less brittle, and way, way easier to work with than its tougher cousins.
And you can really see the difference when you put them side by side. Mild steel is super ductile. That just means you can stretch it and bend it without it snapping. It's not brittle, and it welds like a dream. High-carbon steel? Sure, it's harder, but it's also a real pain to shape and weld. That low-carbon content is basically mild steel's superpower, making it the absolute champion of fabrication. So how do you go from a plain, flat sheet of metal to, well, a car door or a bridge beam? That whole journey is called fabrication.
At its core, fabrication is kind of like a three-act play. First, you've got to cut the steel to the right size. Next, you form it, giving it a three-dimensional shape. And finally, you join all the different pieces together. Simple, right? But the magic is really in the details of each step.
Let's talk cutting. You've got options, each with its own pros and cons. Shearing is your workhorse. It's fast and cheap for simple, straight cuts. Plasma is what you bring in when you need to rip through thick steel quickly. But if you need super complex, detailed shapes with incredible precision, laser cutting is the undisputed king. We're talking tolerances as tight as 1/10 of a millimeter.
Okay, so once it's cut, you have to form it. Turn that flat sheet into something useful. Bending creates angles for things like brackets and frames. Rolling is how you get curves for pipes or tanks. And stamping, that's the secret to mass production, pressing steel into complex parts for appliances or cars in just a matter of seconds. All right, so we know what it is and how we shape it. Now let's get into its personality. Like any good hero, it's got some incredible superpowers and one major weakness. Its kryptonite.
Its biggest superpower is simple. It is cheap. Seriously, you look at it compared to aluminum or stainless steel, and it's not even close. That affordability is precisely why we can build enormous projects like skyscrapers and massive bridges without completely breaking the bank.
And its second superpower is that incredible workability we keep talking about. Because of that low carbon content, it's just so easy to cut, bend, and weld. And that saves a ton of time, energy, and money during manufacturing. It's why fabricators absolutely love it. But every hero has to have a weakness. And for mild steel, its kryptonite is without a doubt rust. You expose it to oxygen and moisture, and it will corrode. This is the single biggest challenge you have to deal with when you're using it. And there's also a bit of a trade-off when it comes to pure strength. Now, don't get me wrong, mild steel is way stronger than aluminum, but it can't quite compete with the raw power of high-carbon or stainless steels. It's in this perfect sweet spot. It's more than strong enough for most jobs, but it does have limits that engineers always have to keep in mind. So, how do we protect our hero from its kryptonite? How do we stop the rust? Well, that's where the final step comes in, giving mild steel a suit of armor.
And there are a few key ways to do this. Painting is the classic choice, right? It gives you good protection, and you can make it any color you want. Powder coating is a step up. It's a baked-on finish that's a lot tougher. But for the ultimate long-term defense against the weather, galvanizing is king. That's when you coat the steel in a protective layer of zinc.
Plating is another really cool option. It's basically like putting a thin metal jacket on the steel. You can use zinc for rust protection, or maybe nickel and chrome for a really hard, shiny finish. You can even use tin for things that need to be food safe.
It's all about picking the right armor for the job.
So once it's all fabricated and finished, mild steel just kinda disappears. It fades into the background, quietly doing all the heavy lifting in the world around us. Let's just take a quick look.
In construction, it is the literal skeleton of our cities. The I-beams and skyscrapers, the frames of massive bridges, the trusses holding up the roof over your head, that's all mild steel, providing that dependable strength.
And in the car you drive? Oh, it's everywhere. It's the chassis that's designed to keep you safe in a crash, it's the body panels that give the car its shape, and it's even the exhaust system. It's what makes cars both safe and affordable.
It's also completely essential to our energy grid. Those long pipelines carrying fuel, the gigantic towers for wind turbines, the simple frames holding up solar panels, they all depend on the strength and low cost of mild steel.
You know, this quote here really just nails it. It's strong, it's bendable, and it's easy to work with. At the end of the day, it's just useful and dependable. And that's exactly why it's everywhere.
So, the next time you're walking around, look at a building, or a car, or even just a simple park bench. Now you know the secret of the unsung hero holding it all together. This hidden material has built the world we live in. The only question left is, what are we going to build with it next? Thanks for joining this explainer.